Hello, Math 120, and this is Professor Gonzalez. And this is the first of many homework videos that I'm going to be doing. So as you can see, this is homework 1.1, and this is out of our My Lab homework assignments. And I'd like to take this time to kind of go over some of these problems, just in case you have some questions. And hopefully I could answer those questions. I just kind of anticipate, taught this stuff for many years, and so I kind of know where the little problems are usually. But let's go ahead and get started with this. This first question is basically asking, I'm going to use a little color here. I love to use color. Basically is asking, is x equals 2 a solution for this equation? That means if I put a 2 in for x, will that make the left-hand side of the equation, here's the left-hand side of the equation, equal the right-hand side of the equation? Will that make the left equal the right? And that's kind of what we're checking right here at this point. So let's go ahead and write this out so I can see it. This is saying 8 times x minus 15, does that equal 1? And I usually like to do a little thing like this, basically showing, question mark, we don't know. So now what we're going to do is we're going to go ahead and put in that value. X equals 2, so I'm going to put in a 2 in here for x. And let's see what happens. 8 times 2 is 16. 16 minus 15 gives us 1, and 1 definitely does equal 1. So this would be yes. Yes. X equals 2 is a solution for this equation. We're going to do this again. 8 times x minus 15, does that equal 1? Now you might be thinking, hey, if x equals 2 works, nothing else can work. And with these linear equations, that's true, but with some equations, well, that's not true, I should say. With these linear equations, it could have one solution, but it could also have no solution, and it could also have infinitely many or all real solutions. So the fact that it has a solution doesn't mean that it doesn't have many, many more solutions. Anyhow, but most of the problems you've seen have kind of worked that way, where it just has one solution and they don't have any other options. But we're going to look at the other options a little bit later. Let's continue on here, and we're going to look here at what happens when x equals negative 2. So now we've got, oops, go back to that. 8 times negative 2. Does that in fact work? Well, 8 times negative 2, that is in fact going to give me a negative 16. And negative 16 minus 15 gives me a negative 31. And that does not equal 1. So this is no. X equals negative 2 does not give me a solution to that equation. Let's try this again. 8 times x minus 15 equals 1. Does this x equals 1 work? So we replace x with 1 and see what happens. 8 times 1 is 8. Minus 15 gives us a negative 7. And negative 7 is definitely not equal to 1, so we say no. X equals 1 is not a solution to that equation. Okay, we're going to do the same thing again, but with a slightly more difficult equation. Slightly, not too much more. Here's the equation. It says 3 times the quantity of x minus 1 equals 2 times x plus 4. And the color today is going to be blue. So, well, why is that not working? Try that again. The color today is going to be blue. Okay, so is x equals 3 a solution? So we replace x with 3, and there's another x right there. So that x gets replaced with 3. Usually when you're doing substitution, using parentheses to sub in is a good idea, because sometimes when you have negatives or double negatives, without that parenthesis, or actually with exponents, we'll see in the future, the parentheses really can make a difference. But having double parentheses here, I think, is going to just, I don't know, it just gets a little bit cumbersome. So I'm going to leave it out there. Now, let's go ahead and see what happens. So it turns out that 3, now when you're up here with a parenthesis and a variable inside the parenthesis, you're going to use distributive property, which you still can do here. But because 3 and 1 are like terms, you might as well just subtract them. 3 minus 1 is 2, and 3 times 2 is 6. Now on the right hand side, I get 2 times 3 is 6 plus 4. That gives me 10. And this is not looking like a solution. So this is no. 3 does not make both sides of the equation equal, so it's not a solution. We're going to try another color here. How about red? X equals 7. Is 7 a solution? So I'm going to go ahead and write my equation. 3 times x minus 1. Does it equal 2 times x plus 4? And we look by getting our red x. So replace x with 7 and replace x right there with 7. Now we simplify and see what happens. 7 minus 1 is 6. 3 times 6 is 18. 2 times 7 is 14. 14 plus 4 is 18. And I think we have a winner. Check, that is true. Oops. There we go. That is true. 7 makes the left side equal the right side. So on this particular part, this is a yes. 7 is a solution to the equation. That's sloppy filling in the bubble. Anyhow, let's go to another color and then we'll be done. Can you actually see yellow? Yeah, kind of, not too well. Yeah, that's never really the best because it gets so hard to see. But we got 3 times x minus 1. Does it equal 2 times x plus 4? We replace that x value with negative 3. Yeah, that sucks. Can't see that at all. Green. Or maybe it's my old 51-year-old eyes that can't see it. But anyhow, replace x with negative 3. And let's go ahead and simplify. We've got negative 3 minus 1 is negative 4. Of course, that gets multiplied by 3, which is negative 12. And on the right-hand side, we've got 2 times negative 3 is negative 6, plus 4 is negative 2, which does not equal. So no, negative 2 is not a solution to the equation. Okay, now we change it up a little bit. Those previous problems, they actually gave us possible solutions, and we checked them and said yay or nay, or yes or no. Now they're not giving us a solution. They're just giving us an equation and saying, can you please tell me the answer? Now I can just guess and throw a bunch of problems in there, or answers in there, but that would take forever. So we've come up with a way of solving equations, and that is called isolating x, or getting x, or 1x by itself. And the way we do that is by using the addition or multiplicative property of equality, which this is basically saying that if I do the same thing on both sides of the equation, now don't multiply by 0, don't divide by 0, but if I do the same thing on both sides of the equation, my new equation will give me the same answer as my old equation. Okay, so this is what I'm talking about. If I want to ultimately know what x equals, right? If I ultimately want to know that, I've got to get x by itself. Even better yet, I've got to get 1x by itself, and then whatever's over here is my answer. So you want to kind of think of this like balancing this equation, or not balancing the equation, that's the wrong word, isolating x, but you want to keep the equation true. That means whatever I do on one side, I must do to both sides. Now I want to get x by itself, and x on the left-hand side, there's an x, and it has 6 times x plus 3. That 3 is obviously it's in the way because I want to get x by itself. So if I subtract 3 on the left side of the equation, I must also subtract 3 on the right side of the equation. That keeps the equation balanced, like a balancing teeter-totter, right? It did the same thing on both sides. And when you do that, of course, positive 3, negative 3, that's 0. And then, so let me take this and rewrite it over here. So that is 0, so I'm left with 6x, and then I have the equal sign, right? And 27 minus 3 gives me 24. Right, that's right there, 24. And now my last step, in order to get, that's really messy over there. In order to get 1x by itself, I need to somehow turn this 6 into a 1. That sounds illegal. But if I divide 6 divided by 6, that's going to turn it into 1. 6 divided by 6 is 1. If I divide the left by 6, I must also divide the right by 6, keeping the equation balanced. And 6 divided by 6 gives us our 1x. And you don't have to write a 1 in front, or you can, but usually at this level of algebra, we don't write the 1 there. It's just sort of implied. And on the right-hand side, 24 divided by 6 is 4. So the solution is 4. The solution is, why isn't that writing? The solution is 4. You can see these other answers here. The solution is all real numbers. Well, no, we've got 4. The solution is the empty set. So I'm going to have to tackle these two ideas later on. But right now, we just have one solution, and that is 4. Let's go on. Next problem. Want to isolate the variable, so you want to isolate the z. So essentially what you're going to want to do is do what? Well, now your first step usually is simplify, and if I just take a look at this left-hand side, 7z plus 2, they're not like terms. I cannot simplify that. So that is simplified. And on the right-hand side of the equation, it's just 1. So in terms of simplification, there's nothing for us to do there. But what I do want to do is I want to isolate the z's. So my first step is by subtracting 2 on both sides of the equation. And when I subtract 2 on both sides of the equation, of course that zeroes out, leaving me with a 7z equals 1 minus 2 is negative 1. Really don't have the best spacing on here. 7z equals negative 1. I need to isolate the z. I need to turn that 7 into a 1. So I've got to divide by 7, right? Dividing by itself just gives us a 1. I must do the right-hand side as well. And we end up with a solution. 7 over 7, or 7 divided by 7, gives us 1z. And the answer on the right-hand side is negative 1/7. Okay. So we got ourselves an answer, negative 1/7. A is the solution. Okay. Or A is the answer, but the solution is negative 7. Okay, now, next problem, looks like we have a little bit of simplification that could happen. Once again, there is the equation. I'm going to see if I could zoom in. Maybe that gives me more space to write. Okay, so the thing about this, on the left-hand side of the equation, I have a couple of like terms. And because I have like terms, I want to simplify first before I try to isolate the variable. Negative 3w plus 2w gives us negative 1w. And the rest of the equation is just plus 6 equals negative 8. Now I want to get w by itself. And w has something that's in our way, in some ways, right? That's 6. So I want to get that 6 away from the w. So I'm going to do its inverse or opposite, which would be minus 6. If I subtract 6 on the left, I must subtract 6 on the right. So that means I'm left with negative w, this is a 0, equals negative 14. Okay, I'm going to rewrite this up here. Negative w equals negative 14. Now the thing is, a negative w, you could think of it as negative 1w. But one way you can, so you want to turn that negative 1w into a positive 1w. So two ways you can do that. You can do that by dividing by negative 1, or probably something that more people would commonly do is just multiply by negative 1. Because a negative times a negative is going to make this ultimately a positive w. Now if I multiply the left by negative 1, I've got to multiply the right by negative 1. And when I do that, I end up getting w equals 14, positive 14. Okay, so when you get to this step right here, this is intermediate algebra. So really, I'm showing all these extra steps, like showing this step here, is really not something you really have to do. I mean, because it's just I'm just trying to make sense of things for people that are forgetting some stuff. But if you get to down here at this line where it says negative w equals negative w, it's just negate both sides, so it's w. So w equals 14. Okay. By the way, this is the solution is 14. Let's move on. Ooh, I think I better zoom in on this for sure. So on this one, once again, here's our equation. And so you've got a left and a right side. The first thing you want to do is simplify the left side and then simplify the right side. And it looks like I can do that because I've got some like terms. 9x and you have to take that sign. Okay. Let me talk about that for a second over here on the side. You probably, something called the addition property of equality. That just basically says if I take, let's say, 4 plus 3, that's going to be the same thing as if, would I say the addition property of equality? No, I don't even know what I just said. Commutative property, and that means if you commute or change the order of this with addition, the outcome will be the same. So 4 plus 3 is the same as 3 plus 4. So that's commutative property, okay? Now the problem is that doesn't work with subtraction. 4 minus 3 does not equal, looks like people are coming over to my house right now. This is great, and I do not want to stop this lecture because I've already stopped it once with technical difficulties, so I've got to keep on going. I'm a little distracted, thinking about outside people walking around and me, so I'm probably going to say weird stuff. Anyhow, 4 minus 3, that does not equal 3 minus 4. Notice we changed the order with addition, and that wasn't a problem. But when you change the order with subtraction, that's definitely a problem and not equal. So what I'm trying to get at is, in this problem, we had a subtraction. We had this sign right here, right? And so if you had, let's say you had 5 minus 6. We just said you can't commute it because it's subtraction, right? However, if you rewrite this as an addition problem, 5 plus a negative 6. Now this is just the explanation of what's going on. I probably wouldn't do all this stuff when I'm doing the problems because, intermediate algebra, you kind of accept this already, right? 5 minus 6 is the same as 5 plus a negative 6, which means we're allowed to commute it, which means a negative 6 plus 5 is the same thing. So what I'm trying to say, and maybe in a really long way, is that normally you cannot use the commutative you cannot, what just happened? Something just disappeared on me. I'm starting to run into technical difficulties. Okay, there we go. Normally, you see this -6, and you cannot commute it. You can't move it around. But why are we allowed to move around -6? Because we're thinking about it as plus a -6, right? Instead of -6. If it was -6, you couldn't move it around. But if you think about it as plus a -6, well, then you could move it around all you want using the commutative property of addition. So that is a bunch of information that explains why we're able to move it around. And a lot of people just move it around. And then some people get caught up and say, is that a subtraction or not? Yes, it's a subtraction, but we think about it as plus a -4x, which allows us to move it around. In a nutshell, what does this mean? It means that I can combine these right now. Let me get rid of that. I can combine these as long as I take that sign. You have to take the sign. 9x and a -4x leaves us with a 5x. And of course, we still have a 2 and a 1, which gives us 3. That's called simplification. On the right-hand side, we're going to do the same thing. I have like terms. I've got 8x's here, and I've got a -1x here, which gives me 7x. And I've got a 2 plus 2 is 4. Okay, you can move. Now we want to put an x on the left side or right side. You can move a -7, add or subtract 7x on both sides. A lot of people like or prefer to subtract the smaller amount out because it gives us a positive x value, but mathematically, if you follow the rules, you're going to end up with the same answer in the end. But this gives me a 0 there, so now I have the 3. And 7x minus 5x is 2x plus 4. I'm going to copy this down up here. 3 equals 2x plus 4. Now I want to get x by itself, so what do I need to do? And everybody's going to yell out, whoops, everybody's going to yell out, subtract 4 on both sides. Yeah, that's true. And if I subtract 4 on both sides, that zeroes out, which leaves me just a nice 2x on the right, and 3 minus 4 is -1. And our last step, remember, is we always want a 1x. So we wanted to turn this 2x, or this 2 into 1x, by dividing by the same coefficient in front of the x. If I do it on the right, I must do it on the left. And so therefore, 2 divided by 2 equals 1x, which equals a half. Sometimes when people see halves or fractions, they panic and figure it's wrong. We could actually put this value back into the original problem and check it like we did on the first two problems. I'll let you do that. I'm going to say A is the solution. The solution is -1/2. Type an integer or simplified fraction. Okay, so when you are doing this on MyMathLab or MyLab, simplified fraction is how you're going to have to type it in. -1/2, right? Don't type in, don't type in decimal values. Even though -0.5 is exactly equal to it, but we run into problems like typing in decimal values for 1/3 because you'd have to round. We usually don't like that. So it says use simplified fractions, no decimals. Let's take a look at this next one. Solve the following linear equation. And in the parentheses, we have unlike terms. So how do we break that down? We use something called the distributive property. So we distribute, let's say we distribute the 9. I'm going to zoom in a little bit. So we distribute the 9. 9 times x is 9x. And 9 times 3 is 27. Okay, now on the right-hand side, we have a -9. We want to get x by itself. And in fact, when you're solving equations, you're doing things inverse operations, which means you're actually doing it in the reverse order of the order of operations. I don't know if that confuses more or not, but that's what's happening. You're working in reverse. So you're subtracting 27 on both sides. Makes that 0 out. Let's see what we have over here. We're left with a 9x on the left, and on the right we have negative 27 minus 9, which gives us a negative, 36. And once again, just like I was saying before, we need to turn that into a 1x, so just divide by 9. Divide by 9 on both sides, and there we go. We get x equals negative 4. And that is our answer. A is the solution, or A is the selection you're going to bubble in, but the answer is negative 4 is the solution to that problem. Let's take a look at the next one. Fractions. This gets people a little bit nervous. Now here's the thing about fractions. You can clear fractions with equations. Don't try it with expressions, but with equations you can, because you have an equation. You can do the same thing to both sides. So let me take a little note here. See space-wise. Okay, let's take a note. Clear. Why did this just change? It just got dark all of a sudden. Clear fractions. On an equation by what? By multiplying by the LCD. LCD is the least common denominator. It's the number that 5, 20, and 4 all go into. It's the smallest number, so that makes it the least. So the least common denominator here, LCD, is 20. 20 is the smallest number that 5, 20, and 4 go into. Let me see if I could rewrite this over here. I'm not sure if I have space to do this or not, but I think I'm going to try this. Say 2y over 5. Then I'm going to say minus 9 over 20. Say equals y over 4. And what did I say? I wanted to multiply both sides of the equation by the LCD. So that means multiply the left side by 20. I'm going to distribute to both pieces, both terms rather. And so I just distributed 20 to this term and then this term, and then on the right side of the equation, I must multiply this also by 20. Now what I want to do is I want to reduce or simplify common factors. Now most people at this stage of the game, intermediate algebra, they're just going to say, well, 5 goes into 5 once, 5 goes into 24 times, and that basically what you just did is you just reduced out the 5 divided by 5, which is 1. Okay, and so that's fine to do it that way. That's actually the faster way to do it, and that's all good. And really what we want to do is see what do we have left, and what we have left is 4 times 2y, and that makes 8y. And a 1 on the bottom, which divided by 1 doesn't change the number. And then you can also see, oh, what do we have over here? Common factors of 20, so those will just reduce down to 1, and we're left with minus 9. The other way people do this when they're, beginning with this stuff, I guess, is they would take 20 and say, well, 20 is 5 times 4. And then they'd say, oh, I see common factors, a common factor of 4, so I'm going to reduce out those common factors, and there you go. And you're left with 5 times y, which leaves us 5y. Okay, so that was a pain to do, but guess what? Instead of solving for y with that equation, we get to use this equation. Much better, right? Go ahead and answer yes. So now what you're going to do is I want to get all the y's on the same side. Okay, got y's. This is the equation. I've got y's on the left, y's on the right. I want them all on the same side. So you could either put them on the left or the right. Doesn't matter. Okay, I tend to want to just move them away since I already have a constant over here. I tend to want to move them to the other side. Some people will say, well, I always put it on the left, or some people say I always subtract the smaller amount. all that stuff doesn't really matter because there are multiple ways of doing this. What really matters is that whatever you do on the left, whatever operation you do on the left, you must do on the right. So I'm going to go ahead and do it that way. Let's go ahead and say, okay, I'm going to subtract 5y on the right. Means subtract 5y on the left. 8y minus 5y, well, that leaves me with 3y minus 9, and 5y minus 5y leaves me with a 0. Probably not the way I'd do it. I'd probably go the other way, so I didn't. But still, lots of people do it this way. Lots of books do it this way because now you get a nice positive 3y and it puts it on the left. Whatever. Okay, let's see. Oh, this thing is, my pen is messing up. Okay, there we go. Now I have 3y on the left and I've got this 9. I wanna only have y's on the left now that I decided to put my y's on my left. So I'm going to add 9 on the left. I'm going to add 9 on the right. And what does that give me? Zero's out there. It gives me a 3y. That zeroed out equals, oh man, that's a 9, isn't it? Yeah, very sloppy 9. That leaves me with a 9. And where are we at here? And now we want to solve for y. So essentially what we're going to do is divide by 3, right? Always turning this into a 1 by dividing by itself, 3. And 3 divided by 3 gives us y equals 3. Okay, and so there's the final answer, y equals 3. That goes right here. So we get one solution. The solution to the problem is y equals 3. All right. Another fun problem with fractions. So remember what we said. How do we solve fractions? We multiply by the LCD. So I think what I'm going to do is rewrite over here. So I have a little more space to operate, kind of like last time. So what is this? This is going to be y. So we've got y over what, 10 plus 6 equals y over 4 plus 12. Okay, what is our LCD? What does 4 go into and 10 go into? It's got to be the smallest number. Well, that LCD is going to be 20. So I multiply every term on the left by 20, or 20 over 1 since it's a fraction. Distribute to the next term, multiply by 20. It's not a fraction, I'll just call it 20. The next, so on the right-hand side, multiply each term by 20, so 20 over 1. And in the next term also by 20. So remember we reduce. So 10 goes into 10 once, 10 goes into 20 two times. We're left with 2y. 20 times 6 is what, 120? Let's reduce the next fraction. 4 goes into 4 once. 4 goes into 20 5 times. So 5 times y is 5y. And 20 times 12, it gives us 240. Okay, I'm getting a little crazy with the colors here. Now, you see we have some y's on the left and some y's on the right. I want to figure out which side I want my y's on, okay? So I'm just going to follow that general loose rule, which is not a hard, fast rule, to subtract the smaller amount. Let's get a better color. A smaller amount. So 2y is smaller than 5y, so I'm going to subtract the smaller amount out. So subtracts 2y. And what does that leave us with? This zeroes out, leaving us with a 120 on the left. 5y minus 2y is 3y, and we still have this plus 240. Got to get y by itself, so what I need to do is I need to subtract out, right? I've got y on the right-hand side of the equation. I got to get by itself, so I got to subtract out 240 on the right, subtract out 240 on the left. What's the result? Well, that zeroes out, leaving us with this 3y. And what's negative 240 plus 120, negative 120. Okay, so now we've got negative 120, and we need to solve for y, so I need to turn this 3 into a 1. And I can easily do that by dividing by itself. I must do the left side by the same thing. So now negative 120 divided by 3 is negative 40. And 3 divided by 3 leaves me with my y. I've isolated my variable, so I've solved the problem. So the answer to the problem is negative 40. Okay, we're getting there. Decimals. So decimals, I mean, we let you use a calculator in this class, so decimals are no big deal really, but what some people will do with decimals is that if they notice that it's just one decimal place will turn each one of these numbers into a whole number. One place would do that. Well, then they just move it over one place. But technically what you're doing, if you're going to do that, is you're going to multiply every term on the left by 10 and multiply every term on the right by 10, which when you multiply by 10, it just moves a decimal to the right one place. So for some people, they would view this without decimals, move each decimal to the right. So 0.7 becomes 7x minus 6.1 is now 61 equals, now negative 2.6 is now negative 26. And that new equation will give you the same answer as the old equation. And let me just say that about this last problem as well. We started off with this kind of messy equation, and by multiplying both sides by the LCD, we got to work with this less messy equation, no more fractions. Okay, so that's sort of the point with that. Let me zoom in and see if we can do this. We need to add 61 to both sides. And that gives us 7x equals. What is this one? This is going to be negative 26 plus 61 is 35. And then last step, divide by 7. Reduce, and we get our answer, x equals 5. Okay. Solve the following linear equation. Identify the equation as an identity, contradiction, or conditional equation. Okay, so we've got more things that we've got to fill in here. And let me just tell you, the equations that we just have been doing are all conditional equations. Conditional equation is an equation that is equal based on the condition of an answer, right? So this last one right here, this last problem right here, we can say that this left side equals the right side. Not always, only based on the condition if you use x equals 5, right? So it's called a conditional equation. If you put 6 in there, it won't make the left side won't equal the right side. If you put 100 in there, left side 100 for x, the left side will not equal the right side. But if you put in a 5 in for x, the left side will equal the right side. So that is considered a conditional equation. It's a conditional equation. It's equal based on the condition that you pick the right number. A contradiction is when the left side, like if I said 5 equals 4, that's a contradiction. That's not true. An identity is when the left side equals the same thing as the right side. So we'll get into this, okay? Here we go. So we want to solve for x. Looks like we're going to need to use the distributive property. 2 times x is 2x, and 2 times 4 is 8. Okay, some people might see something coming, but might not, because we're sort of in this robotic mode here. Let's get x's together. So let's subtract 2x from both sides. And something that hasn't happened yet is going to happen right now. The x's cancel out on the left, and the x's cancel out on the right. And we have a new equation that says 8 equals 0, and I know This is not true, right? 8 does not equal 0. So let me take a note. When you're solving when the variable I don't know if I'm going to say when solving. Anyways, when solving, when the variable drops out or disappears, when the variable drops out or disappears, and you have a not true, maybe we just call this false. When the variable drops out and you have a false statement, and that kind of goes with this guy right here I'm talking about, right? You have something called a contradiction. And the solution is the empty set, which also you can just say no solution. Okay, so over here you can say when the variable drops out and you have a false statement, the result is no solution. Okay, that'll be true with these equations. Let's try another one. Number 12. Yikes, look at that. Okay. Well, that's a big old mess. And what you want to do first when you have a big old mess, there's the equation, equal sign. You got a left side and a right side. When you have a big old mess, you want to simplify, meaning clean it up first before you try to isolate the variable. So let's do that right here. Let's try to clean it up. It's called simplification or simplify. 2 times y is 2y. 2 times 2 is 4. You must distribute the negative. So negative 5 times y is negative 5y. Most students get that. But here's where a lot of students will mess up. Negative 5 times negative 3 is positive 15. That's a common mistake right there. Equals. Now let's deal with the right. Well, the right side is already distributed and simplified somewhat, but it's the like terms are not together yet. How about 7y, don't forget the sign, and a negative 10y, which gives us what? Negative 3y. Don't forget that we also have this 19 here. 19 minus 3y. Now on the left-hand side, there's definitely some combining that can take place. So let's do that. We've got a 2y minus 5y, which is negative 3y. We also have a 4 and a 15, which is 19. So we've got negative 3y equals negative 3y. I'm going to use the same color. Whoops. Okay. So some people might at this point say, wait, the left-hand side is exactly the same as the right-hand side. And if you're saying that, that's called an identity, and you're right. But some people will be in autopilot mode, and they will, like a robot, want to get the x or the y's together. So they'll say, I'm going to add 3y to both sides. And that's going to zero out, giving me a new equation that says 19 equals 19. Well, that's true. When the variables drop out and you have a false statement, there's no solution. When the variables drop out and you have a true statement, the solution is going to be all real numbers. All right, let's take a look at a couple more here. So solve. We're going to add 10 to both sides, which gives us 2y equals 1. Going to divide by 2, which gives us y equals a half. Okay, where are we at here? Just making sure I'm not missing something I wanted to say. Yeah, identity, okay. Okay, so now this is like many of the problems we did before. It's just that this one wants us to answer the question, state whether the equation identity, contradiction, or a conditional. And this is considered conditional. And why is it conditional? Because this left side equals the right side based on the condition that you use what? That you use y equals half. So this is it has a solution and it's a conditional equation. We're almost there. Number 14. Use distributive property to start to simplify. 6p, 6 times 2, 12. Distribute the 5, 5p. Distribute the 5, never forgetting the negative. 5 times negative 3 is negative 15. Plus p, plus 27. Now once again, here's the equal sign. And before I start isolating, I want to clean up, simplify, combine like terms. And this is 5, let's see. So 5p plus 1p is 6p. Okay, and then what else do we have? We have our negative 15 plus 27, which gives us 12. Negative 15 plus 27 is 12. And on the left-hand side, we have 6p plus 12. Oh, wait a minute. Both sides are identical, which means it's an identity. And identities have all real solutions. No matter what you put in for p, the left side's going to equal the right side. Your lucky day. Okay, last one, number 15. This is the granddaddy of them all here. Let's go down here and give myself a little more space to work. So this thing says 3b minus 2 times the quantity, b plus 1 minus b equals 9 times b minus 1 minus 9b. Okay, there's our equal sign. We need to begin to simplify, and I'll tell you, common problem right there is forgetting to distribute the negative. So this is a minus or negative 2b, and negative 2 times 1 is minus 2. That is a problem you got to be careful with. Distribute the 9. 9 times b is 9b. 9 times, don't forget, negative 1 is negative 9 minus 9b. Now we want to combine like terms. Once again, equal sign. 3b minus 2b is 1b minus minus 2 minus b. Over here we've got 9b and a negative 9b, which zeroes out, leaving us with negative 9. And we also have a positive b and a negative b, which zero out, leaving us with a negative 2. Does negative 2 equal negative 9? No, it doesn't. That's false. So that is a contradiction, and contradictions have no solution. And this book likes to call it the empty set, which is the same as no solution. All right, I hope that helped out. This is Professor Gonzalez. That was a funny way of saying that. This is Professor Gonzalez signing off, and I hope you have a great day. Bye.